Now that you've had a chance to look at some of the other bases here in the module, I want to take this time and opportunity to explore them with you. Here we have the 3-to-1 machine. So in this situation, each group of 3 dots will explode, move to the left, and make a group of 1, otherwise known as base 3. Let's take a look at an example. What if we had 29 dots? What would that code be in the 3-1 machine or in base 3? So we have a couple different ways that we can do this. We can put in 29 dots, circle groups of 3 and see what happens. We could think about groups of 3 and maybe keep track of those moving from right to left. Or we could even think about what each dot represents in each one of the places. So I'll start with the most elementary one of those on this example, and maybe as we go, I'll do something different. So if you were to put out 29 dots, the first thing you'll notice is it takes a lot of time. So I will put them in rows of 6 so that it makes it a little easier to find groups of 3. Let's see, 24, 25, 26, 27, 28, 29. Okay, so once I have my 29 dots, I'm looking for groups of 3. I would circle those. There's a group of 3. It will explode and make 1 dot to the left. And then I will just repeat this process however many times I can find groups of 3. And you could think about here, and you could pause the video or just think about it while the video is running. Is it necessary to draw all of these dots to think about how many groups of 3 I am going to have? Yes or no? So there we go. I found a grand total of 9 groups of 3. You'll notice that I have 2 dots left over this time. This is a little different than in the 2-to-1 machine, where I can only have 1 dot left. And since I have 2 dots left, I'll note that in the code by putting a 2 in this particular place value. Then I'll just continue the process in the next place, looking again for groups of 3. All right, we don't want to switch back to 2 on accident, although that can happen with students. So be careful to stay in the correct machine. So circling a group of 3 and exploding, move it to the left. Circle a group of 3, explode it, move it to the left. Circle a group of 3, explode it, move it to the left. And we exactly have 3 groups of 3. Okay, so there's no dots left in this place. So I will note that by putting a 0 at the top. And then I can circle another group of 3 in this place and explode, move 1 to the left. And notice that I'm left with 0 dots in that place and finally 1 dot in that place. And that gives me my final code of 1002 base 3. So I'm going to write THREE at the bottom there. Okay, let's take a look at some other bases. What would happen in base 5? Let's try a different technique this time. In base 5, let's take a look at an example where we have, let's see, the same number of dots, which would be 29, I believe, that I did last time. All right, so 29 dots. Well, I don't want to draw out all 29 this time. So instead, I'm going to think about if I'm making, in this case, groups of 5, right? We're in the 5-to-1 machine. How many groups of 5 would I have if I were to draw them out? So this is another technique you can use. You can think about 29 dots in this first place, but not actually draw out the dots. And think, well, let's see, 29 groups of 5. 29 divided by 5 is 5, and I would have 4 left over. So you can write it in that way. You can think, well, I'll have 5 groups of 5. So I'm going to put 5 dots to the left. 5 times 5 is 25, but I'll still have 4 dots left in here. Okay, that gives me progress. Now, in base 5 or in the 5-1 machine, we have to have a whole group of 5 before it can explode. So those 4 dots will not explode, and we'll just be left with a 4 in that place. I'll put a 4 at the top. However, in the second place over, there are 5 dots. So those will explode one more time. I'll circle that group of 5. Remember, it must be a group of 5 and move 1 dot to the left. And so I'll be left with 0 dots there and 1 dot there, leaving me with a code of 104. Remember, don't pronounce it as 104. It's not 104. It is actually equal to 29. So in a different machine or base or code, we will just say 104. We pronounce the digits, and then we let the user know or the viewer know it's base 5 by writing FIVE down below. All right, considering base 8, we'll look at one last technique that we could use here. Let's take a look at that same example of 29. So I could draw 29 dots. I could divide by 8, or I could think about what does each dot represent in each one of these little boxes. Now, each dot I put in here really represents a value of 1. In other words, if I wanted 29, I would put 29 dots in there where each dot has a value of 1. However, when I circle a group, in this case, it would be base 8, and explode and it moves to the left, I'm circling that group of 8. So that what that really means is that if I end up putting a dot in this place, it will actually have a value of 8. Think about that. Have a value of 8. All right. And so I can actually use this idea to build the number rather than drawing the dots and dividing. So I hope that you can catch this last building process. So here's how it would be built. I start with the biggest value, in this case, the second box, and each dot in there is worth 8. And if I know how to count by 8s, it's not bad. Here's how it would sound. 8, 16, 24, 32. Okay, that's too much, right? If I count by 8s, I only wanted to go to 29. So I'll undo that last dot. So there's 3 dots in there because 8 times 3 is 24, or you can count 8, 16, 24. So I'm now at a value of 24, but I still need to get to 29. So 24, but now I'm going to go here. 24, 25, 26, 27, 28, 29. Kind of did a backwards approach. So I put 3 dots there and 5 dots there. And so 29, the number 29 for us will end up being 3, 5 in base 8. 3, 5 in base 8. So that's something for you to think about. Base 10, I don't want to spoil it. I want you to think about what I presented in the module and look at the homework. But this one's very special because this is the one that all of us learn in school. And many of you that are taking this class might want to be an elementary teacher in the future, or middle or high school teacher. Maybe you're not in education, but many people that take this class are interested in that. And this is the base and that we will use in school. And it truly will be a code for the kids that we teach. So lastly, I want to look at a base that is a bit obscure, base 13. And I'm going to use a little bit of a larger number. And I brought a calculator to work with here because it can be helpful. So I'm going to think about the number 150. Okay, wow. Well, if I were to put 150 dots into here and explode them using base 13, what would happen? Well, I know right away that I don't really want to draw 150 dots. So I need to use one of the other techniques. I can either divide by 13, or I can think about the value of each of the places. So I'm going to go back to the second technique where I divide by 13. So I'm going to grab my calculator. I'm going to do 150 divided by 13. And I see that I have 11 point some decimals. It's pretty messy, actually. So what that means is that 150 divided by 13 is equal to 11. And then we have a remainder. Now, what is the remainder? Well, how can we figure that out? Think about that. Well, if 13 goes into 150 11 times, check 13 times 11, and you'll see that it's 143. So if that's 143 of the dots, then I would have how many remaining? That's correct. There would be 7 left because 143 plus 7. So what that means is I would have 7 dots left in this place after I found groups of 13, but I would have 11 dots that would move over here. Okay, so that becomes a little bit tricky. How do I write this code? Well, in the first box, I can see I have a grand total of, I don't want to circle those because I don't want you to think I'm going to explode them, but I have a grand total of 7 dots. So on the code, that would be a 7. In the next box, it's kind of an odd thing. They have, there's 11 dots, but I can't explode any because again, I'm looking for a group of 13. So I want to write 11 up here. Now that gives me pause though, because if I write 11, 7, people might think I'm writing 117. And I'm like, no, I'm writing 11, 7. So this is confusing. So what we do when we have a base larger than 10 is we have to create some new digits. So the digits for base 13, let me write that out front. Base 13 digits would be the standard digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, like we always use. However, since it's base 13, we're also possible can have a group of 10 11, or 12. We can't have a group of 13 because it would explode. So the way that we'll denote 10 is we'll use an A. A for 10, B is 11, and C is 12. In this example, since we have 11 dots here, that's going to be our B. So what I'll do is I'll write B at the top. And that means, oh, this is a little weird, I know, that my final code is B7 base 13. All right, I'm sure you'll have fun with this. Hope to see you in the next